In August 2009, a new network of scientists, technologists, industrial experts and policymakers was created. Its name is EULASUR, and for 3 years it has been promoting international research collaboration between Europe and Latin America in the field of material science. Novel materials are in continuous demand because many of the well-established materials, such as metals or plastics, cannot fulfill all technological requirements for the constantly growing new applications and challenges. Clean energy, future electronics, and new medical developments will run on materials that right now are being designed and analyzed in the lab. Advanced functional ceramics, hybrid materials, and nanomaterials represent some of the most promising and fascinating developments in material chemistry in recent years. And its industrial interest grows as research shows their tremendous possibilities of application. EULASUR is a European FP7-funded project that focuses on these advanced materials and nanomaterials. Its objective is to foster international collaboration and gain first-hand knowledge of the state-of-the-art research in these fields. Professor Carlos Meravillas from the Institute of Material Science of Barcelona of the CSIC coordinates the project.
EULASUR es una plataforma de cooperación que promueve la alianza estratégica de investigación entre científicos, responsables políticos, técnicos, responsables de transferencia de tecnología, expertos industriales de la Comunidad Europea, de todos los países de la Comunidad Europea y de 3 países de América Latina, en este caso concreto, que son BRAU, Brasil, Argentina y Uruguay.
Suzanne Becker, EC officer of the project, emphasizes the importance of funding research areas with such future economic opportunities and industry applications as advanced materials and nanomaterials.
It can contribute to growth and to creating jobs and making industry more competitive. This is a very important topic to subsidize, really. Yeah.
Professor Leif Bloch Rasmussen from the Copenhagen Business School remembers the impact that these novel materials will have on society.
You need to have competitive advantage together with economic growth, and that equals social cohesion and sustainability. So it's all these 4 together, I think, can benefit from nanotechnology or materials research.
Several activities were organized to achieve EULASUR goals. 2 summer schools held in Argentina helped developing strong bonds between researchers and promoting interactions among groups of excellence. Research ideas, results, and perspectives were shared, and areas for possible future collaborations were identified. A first workshop was organized in Brazil under the title From Materials to Products. It was focused on how to obtain innovative products from novel materials, taking into account not only costs and manufacturing methods, but also environmental impact, safety, and disposal. The second workshop took place in Copenhagen. This time, the topic of interest was another key factor to competitiveness: the necessary collaboration between industry and public research. Other brief workshops of 2-day duration have been organized in Argentina and Copenhagen to maximize and obtain specific partner collaborations. The EULASUR Research Exchange Implementation Plan enabled a total of 19 exchanges among EULASUR partners to increase interaction among researchers and students. As part of EULASUR activities, a survey was developed to identify key areas of common interests. Professor José Luis Briançó of the Universitat Autónoma de Barcelona was in charge of this activity.
En la encuesta que hemos llevado a cabo hemos seleccionado, o se ha seleccionado mejor dicho, 5 tipos diferentes de materiales de interés común entre América Latina y Europa, que son los siguientes. En primer lugar, los materiales cerámicos avanzados. En segundo lugar, cristales moleculares con aplicaciones en farmacología. En tercero son los nanocristalinos, materiales nanocristalinos, los materiales en cuarto lugar de bajo nivel de fricción, evidentemente con gran interés industrial, y por último los biomateriales.
Advanced ceramics production is still small compared to traditional ceramics such as tiles, tableware or sanitaries. However, their high value-added nature yields impressive average annual growth rates. As much as 60% of all advanced ceramics produced are used in electronics. Today's cellular phones, electronic components in motor vehicles, and household appliances run on advanced ceramics. Other applications of these materials include low-friction coatings such as the ones that avoid erosion in aircraft turbines, health information systems, and pollution control technology. Given the worldwide attention being paid to a healthy and sustainable economy, the so-called green materials are expected to have an average annual growth rate of 7%. Professor John Kilner of the Imperial College of London explains why advanced ceramics are key materials for low-carbon energy.
There are certain very special ceramic solids in which the atoms move as if they were in a liquid. And we can use that particular property to make them behave as an electrolyte, as they would in a battery. But of all the ceramics that are available, these are a very, very, very small and very selected group of materials.
Hybrid materials are mixtures of materials that show superior properties compared to their pure counterparts. There is virtually no limit to the combinations of components to form hybrid materials, and this initiated an explosion of ideas about potential materials and applications. Biocompatible medical materials like advanced implants in biomedicine, new batteries and fuel cells, and reactive nanoparticles for environmental remediation and pharmaceutical products. Nieves Casañ from the Institute of Material Science of Barcelona of the CSIC points out that hybrid materials were discovered in nature and then developed in the labs for new applications.
It's like the word nano. I mean, nano existed before the word was invented, like the bacteria that have iron oxides surrounded by a membrane that allows the bacteria to orient in the magnetic field, and this is a hybrid with biocomponents, and you don't need to think about it for the material to exist. What it has changed is that at some point we have been able to characterize things in a nano way and to manipulate things in a nano way, and that's why the word nano was invented.
Advanced materials need to be understood before they are put to use in new applications. Today's new imaging techniques allow scientists to see the structure of materials with an unprecedented detail. Carlos Balseiro, from the Instituto de Nanociencia y Nanotecnología de la Comisión Nacional de Energía Atómica, points out that we not only need to characterize new materials, but also model them.
Modeling and characterization work together because complex materials are so complex, are so difficult to understand that we have to incorporate elements that come from the characterization of the material, feed the mathematical models, try to understand how the material will work, and then go back to the lab in order to build up the material, correct the model.
The Eulasaur goal was to facilitate bonds and interactions between institutions researching the frontiers of materials science. The cooperation platform is in place. The project has been a success.
We have discovered other culture, we have discovered other people, but also we have made, I think, good science. And that is important for the education of the young generation of scientists.
EULASUR was a very nice opportunity in order to prepare people that will be the actors in the next years, the real actors.
This experience was absolutely different from the exchange experiences I had as doctoral student, because this time was the stepping stone towards launching a new line of research that would differentiate my own work from what is done in my group and in the institution to which I belong to.
Discover new groups and new teams, which in many cases are working in similar area as we are, but maybe with different perspectives and different means. So I would say the Eulasaur was very useful for this, establish contact and discover new people.
Veníamos rumiando esta idea de aplicar un poco lo que es lo nano al diagnóstico. Entonces, basado justamente en un problema, que es el diagnóstico en aquellos lugares remotos, accesos, zonas remotas, rurales sobre todo, un poco el EULASUR ya desde el primer inicio empezó a dar un poco de nafta a esa idea inicial que se transformó directamente en un proyecto. Pasó de ser una idea a un proyecto y hoy por hoy estamos madurando la red de colaboradores para hacerlo realidad y empezando ya con los primeros experimentos para después, posteriormente, aplicar a un subsidio.
I have been able to learn from business or from project management and so on, and to create new ideas. And some of the exercises came out to a very nice interaction between engineers, philosophers, psychologists.
Nowadays, you cannot do research alone. No matter how large or how rich is the country where you are, you always need cooperation at the global level.
As a scientist, one is always worried whether one's methods are working in other cultures. And in this case, it has been such a big surprise how we were able to collaborate with the Argentinians and actually run innovation processes with business, with citizens, and with researchers and students participating.
It's been 3 years of exchanges, workshops, and summer schools. A solid network of key players in material science has been established. Now it's time to look ahead and keep on the work promoting international research collaboration in the field of material science.
Hemos pensado que esto es simplemente un primer paso. Pensamos que eso debe de continuar. Con la experiencia adquirida y las relaciones establecidas en EULASUR, pues será posible con otros actores, una parte importante de otros actores, establecer una nueva plataforma más focalizada en algunos temas concretos.